So look at example 2. Let's just simplify that. How many terms do you have? 2. Remember, terms are separated by plus or minus signs. So you have this term minus that term. What do you notice about those two? How can I simplify this?
Take out secant x.
They both have a secant. So I can take out a secant. And so if I take it out of the first one, I just have my sine squared. Minus, take it out of that one, what's left?
1.
What else can I do?
That's about it.
That's about it.
No, I see a squared and a 1.
Oh, could you...
Square root.
So anytime you see a square trig function and a 1, you need to check your Pythagorean identities. So when I see that there's a Pythagorean identity, over here it's going to be kind of my think bubble. It says sine squared plus cosine squared equals 1. And I need 1 and sine to be on the same side. So I'm going to move the sine squared over. And so I got cosine squared equals 1 minus sine squared. Is that what I have right there?
No.
It's not, is it?
No.
But what do you notice about them?
It's close enough.
It's close, so let me put the 1 first. So I have my secant of x times, I have a negative 1 and a positive sine squared. Well, obviously it's not the same thing because it's the same equation, I just changed the order. But now what's different between that one and this one?
Multiply by -1 so you can change the sign.
Both of the signs are different, aren't they? In the one I have up in my think bubble, I have a positive 1, I have a negative 1 in my problem. In my think bubble, I have a negative sine squared, and I have a positive sine squared in my problem. So I could take a negative 1 out. So I'm going to take out a negative. So I just put it at the beginning. And when I do that, I'm dividing these both by -1. And so I get that. Now, is that the same as what I had up there?
Yeah.
Sort of.
It is. So I'm going to bring down my negative secant of x. What is 1 minus sine squared equal to?
Cosine.
Can I do anything else?
No.
Are you sure?
No.
I didn't think so.
Wait. 1 minus sine squared. Oh, there.
All right, so here y'all saying something about secant and cosine. So what are y'all telling me? Cosine is what? But this is squared, so what is cosine squared? 1 over secant squared. Remember, everything but the Pythagorean identities, you can switch back and forth from being squared and not squared. Pythagorean identities have to be squared. So what good does that do me?
It's just
Well, if I put it together, I got a negative secant of x over secant squared, right? Yeah, we're multiplying, so you can multiply straight across. Now what?
You can get rid of 1 of them.
Good, you got a secant on top and 2 of them on bottom, so get rid of 1 of them.
Yeah, make it -1 over secant of that.
Good.
no. That's it.
No, that's it.
Nope.
No, there's more.
What?
What is 1 over secant?
Let's look.
It never ends.
Cosecant.
So I got a negative cosecant of x. And now it's only one term. You can't get much smaller than that, right?
No, cosine. Cosine.
Oh, you're right. You're right. Thank
I
you.
was looking. I was like, what is this?
Sorry, I just followed right along with what he told me. I know. All right, so there we go. Now, is that the only way we could work this problem?
No.
No. I was good with y'all until you got to this point, and then y'all went separate than what I did. Okay? I changed secant to cosine. It doesn't matter, though. We get the same answer in the end.